transaction in a database management systems. Transaction means it is a logical relation operations. It is a result of request made by the user to access the content of the database and perform operation on it. That means when you want to access a data in a database, when you want to update a data in a database, when you want to look at data in a database, you must use a transaction. So transaction is a request or a set of requests or a set of logical operations. Uh, it consists of various operations and has various states in a compilation journey. Some it also has some specific properties that must be followed to keep a database consistent. Um, a database transaction is a unit of transactions with a database management system or smaller systems that treated in concurrent or related reliable way of independent of other transactions. Next, transaction processing system. What does a transaction mean in a database management system? It is a set of logical related operations. It is the result of requests made by the user to access the contents of the database and perform operations on it. And also it consists of various operations and has various states in it in a completion journey. It has some of specific operations that must be followed to keep a database constant. So data in database management system, a transaction means it may be a whole operations or the specific one operations, we call it as a transaction. Transaction processing system. In a database field, a transaction is a group of logical operations that must all successed or failed in a group system. System dedicated to supporting such operations are known as transaction processing system. So in order to control a transaction is successed or failed, it is important to manage or this operations also we call it as transaction processing system. These transaction processing systems contains TP monitor, application program, and database management system operations. TP monitor or transaction processing monitor is a system that manages transaction. Application program is a series of transactions with none database processing. Is business transaction versus online transaction. Business transaction is a transaction in a real world, usually between in enterprise or in person, where something is exchanged or something physical things can be exchanged. The other one is online transaction. This transaction executes in program formats, administratives, or real-time functions, often by accessing shared data sources, usually in behalf of online users. So users can access data in digital data. We call it as online transaction. Transaction can be started, attempted, and then committed or aborted via data manipulation command or a square. So when a users wanted to fetch or retrieve or update some data, this structure can be followed. When you come to properties of transaction, there are four basic properties of transaction. Acid property, A, atomicity, C, consistency, I, isolation, and D, durability are four basic properties of uh, transaction. Atomicity means all or nothing property. This means that uh, a transaction needs only two options. That means either done or never started or never done. Second property is consistency. Must transform data from one consistency to another consistent status. If a transaction code is correct, then a transaction at a transaction at the end of the execution must have a database consistency. Transaction should transfer this constant state or update to consistent status. Isolation, partial effects of incomplete transactions should not be visible to other transactions. Uh, Transactions must execute without interference from other concurrent transaction. So, without any interference, transaction must be committed or must be done. This property called as isolation property. The other fourth one is durability property. The effects of committed transactions are permanent and must not be lost because of later failure when updations are executed in transaction. So this updation must be constant or permanent updation in a database files or in a database table. When you come to operations of transaction, let me some of operations, read operations, write operations, uh, commit operations, and rollback operations. First, read operations. Read operation is used to read the value of x or the data of x from the database and stored in buffer in main memory of the further actions such as displaying the value. Read operations, such operations is performed when users wish just to see any content of the database and not make any change on it. For example, when a user wants to check her account balance, read operations would be performed on user account balance for a data. Write operations in order to update or in order to changing the value in main memory. For write operations to be performed, for first read operation must be executed. Um, for example, when a user requests to withdraw some money from his account balance is fetched from a database using read operations, then account could be changed from previous constancies to new consistent state. Next, commit property. These options in a transaction is due to maintain integrity in a database. Um, Integrity in a database due to some failure of failures in case of maybe power hardware failure, software failure. A transaction may get interrupted before all of the operations are completed. This may cause ambiguity in the database. It might get inconsistency before and after a transaction. So commit transaction is used to maintain integrity and confidentiality in a database. To ensure that further operations of any of transaction are performed only after a work of concurrent transaction is done. Commit operation is performed to change made by a transaction permanently to a database. The other one is rollback operations. This operation is performed to bring a database to the last saved states when any transaction is interrupted in between due to any power, hardware, or software failure. In simple word, it can be said that rollback operations does undo operations in of a transaction that were performed before any interruption to achieve safe states of a database to avoid any kinds of ambiguity, inconsistency. Um, the main points of the other one is state of transaction. Transaction is atomic operations at all for user perspective, but in a system perspective, there is different status. When users want to modify one account numbers or modify one data items, So transactions start with these pointers. Next in this direction, start commit. That means partial commit in a sense, no error. So partial commit may be okay, maybe correct, correct transaction, go to commit operations, and also finally end of transactions, and also update or changing a database database files. The other direction may be at partial commit status, maybe loss of errors or something have exist in these conditions, maybe system error mostly. Maybe happen a system error that goes that operations this operations goes into abort or failed state. Uh, this operation is also end of transaction. That means abort transactions. The other third option is maybe option is maybe goes to in errors or transaction errors. A transaction initiated at rollback operations also. This rollback operations goes into end of transaction without any changing of or modifying of a database. So ኮንስታንት ስቴቱ እንደጠበቀ ኢንድ ያደርጋል ማለት ነው። የዚህኛው ግን ኮንስታንት ስቴቱ አፕዴት ያደርጋል ማለት ነው። This is the status of transaction in system perspective. The next is ways of transaction execution. We have two ways of transaction execution: serially transaction execution and concurrently transaction execution. Serial transaction execution, these kinds of transaction are executed serially. This transaction T1 completed, and serially execution is when multiple transactions are executed. They are executed serially. In serial execution, any of point of time, only one of transaction is active, or one transaction must be executed at a time. That means no overlapping of a transaction. ጀስት ላይክ ዚስ ትራንዛክሽንስ ኤክስኪዩትድ ሊሆኑ ይችላሉ፣ ግን ሴሪያሊ ናቸው ማለት ነው። ኢን ሴሪያል ስኬጁል at any point of a time only one transaction is executed. There is no overlapping of a transaction, just like this figure. When a transaction 1, transaction 2, transaction 3, good things about serial execution or main advantages of serial correct execution: if input is correct, the output is correct. Fast execution, since all of the resources are available to the active state. That means all resources, maybe RAM, CPU, or any computer resources can be applied in only active state transaction. So fast execution and correct execution is the good thing for serial executions. The worst thing about serial execution is very efficient resource utilization. For example, suppose a data item suppose data item x which equals to 10, y which equals to 6, n which equals to 1, and t1 and t2 are a transaction. So serial, when you execute this two transaction in serially, like this, transaction 1 is first executed, and transaction 2 are executed at the end of transaction 1 execution. This results the final value of x and y. Final value of x and y at the end of t1 and t2, x which equals to 12, y which equals to 7. Thus we can witness that serial executions of transaction. If we have two transactions, T1 and Ti and Ti plus 1, then Ti plus 1 will only be executed after completions of Ti. That means when you have a number of transactions, so first executed one transactions at a time. Next ways of transaction execution, concurrency transaction execution. This is the reverse of serial execution transaction. This scheme, the individual operations of a transaction, the individual operation of transactions are executed in simultaneously. Uh, that means read and writes are interleaved in some orders. Uh, when you execute two transactions, transaction 1 and transaction 2 in concurrency format, concurrently format, T1 reads data item X at T1, T2 reads at a time T2. That means there is interleaving between the two interactions. At the end of T1 and T2, X equals to 11, Y equals to 7. This improves resource utilization, but unfortunately gives incorrect result. Problems associated with concurrent transaction processing systems. Two transactions may be correct in themselves. Interleaving of operation may be produce an incorrect result. An incorrect result when you want to execute transactions in concurrent format. That means there is interleaved between each transactions. The three potential problems caused by concurrency are loss update problem, uncommitted dependency problem, inconsistent analysis problem. Uh, uh, First one is lost update problem. Successfully completed update of a data set by one transaction is overridden by the another transaction before completion of first transaction. The other transactions are access the data items simultaneously. So uh, for example, access account with balance A, which equals to 100. A1 reads the account A 100. T1 withdraws 10 from A. That means 100 minus A. T1 makes update on a data item A. T2 reads the account A. T2 also update data item A by adding 100. T2 makes the update data item in a database. Uh, in the above case, we have done one after the other serially. Then we have no problem. Serial, when you execute serially, no problem. But if they start some times as follow sequence, for example, T1 reads the account A 100, T1 withdraws 10, makes the balance A which equals to 90. T1 reads the account A 100, T2 reads. So in this way, when you look these transactions, T1 uh, T1 start transaction or begin a transaction at a time 2. T2 start a transaction at a time T1. This execution is T1 reads the value, the accounts of A equals to 100. In this way, T2, T1 reads at time T2 value X equals to 100, and also T2 update the value of X plus 100. That means the value changed at here 200, but updation have been executed in this way. So transaction 2 reads this or executed this result at 200. So transaction 2 have interleaved with transaction 2. Transaction 1 have interleaved with transaction 2 before transaction 2 executed. Serially, final balance could be 190. Loss of T2 updates avoided by preventing T1 from reading X until after updating T2 ቲቱ አብዴት አድርጎት እስኪጨርሰው ድረስ መጠበቅ መቻል አለብን ማለት ነው። ቲቱን አብዴት አድርጎ እስኪጨርሰው ድረስ መጠበቅ አለብን። ዛት ሚንስ ኮሚት ከደረሰ በኋላ ማን መቀጠል ይኖርበታል ማለት ነው? ቲቱ መቀጠል ይኖርበታል ማለት ነው። ቲዋን መቀጠል ይኖርበታል። ቢኮዝ አሁን እየወሰደ ያለው ስንትን ነው? ቲዋን የወሰደው ማንን ነው? ፈረስት አብዴት ያልሆነውን ቫሊዩን ነው ማለት ነው። አብዴት ያልሆነውን ቫሊዩን በት ቲቱ ግን ከሱ ቀድሞ ምን አድርጎታል ማለት ነው? አብዴት አድርጎታል ማለት ነው። ስለዚህ ዚስ ዳታ አይተምስ ካን ቢ ኤክስኪዩትድ concurrently but it have a conflict or it have a problem. That means what kinds of problem? Loss update problem. The second one is uncommitted dependency problem. This problem occurs when one transaction can see immediate result for another transaction before it's committed. ስለዚህ ኮሚትድ ከመሆኑ በፊት ትራንዛክሽኑን የሚያነብበት ከሆነ ትራንዛክሽን ዋን ኮሚትድ ሳይሆን ትራንዛክሽን ቱ የሚያነበው ከሆነ ቼንጅድ የሆነውን ቫሊዩ ማለት ነው። just look these transactions, transaction 1 and transaction 2 time here. Transaction 2 starts at time t1, begin transaction, read transaction, update transaction 200. ይሄኛው ግን ስታርት የሆነው የት ላይ ነው ማለት ነው? ትራንዛክሽን ቲ4 ትራንዛክሽን 1 ቲ4 ላይ ነው ማለት ነው። አዘ ታይም ቲ4 ላይ ነው። ስለዚህ አሁን ምንድነው ማለት ነው? ይሄ ቫልዩ ኤክስን በምናይበት ሰዓት when you look the value of x is from this up to this, it's correct, no problem, no problem, but problem can be exist at here rollback. that means failure states በሆነበት ሰዓት rollback እያደረገ ነው ማን? ትራንዛክሽን 2። ስለዚህ ሮልባክ ሲያደርግ ምን መሆን አለበት ማለት ነው? ትራንዛክሽን 1 ማንበብ አለበት ማለት ነው። ቫሊዩ 100 የምትለውን ማንበብ ይኖርበታል ማለት ነው። ማንበብ ይኖርበታል። ስለዚህ ይሄ እንደዚህ አይነት ፕሮብለሞች እንዴት ፊክስ ልናደርገው እንችላለን? ፕሮብለም አቮይድድ ባይ ፕሪቬንቲንግ ቲ1 ፍሮም ሪዲንግ ኤክስ አንቲል አፍተር ቲ1 ኮሚትድ ኦር አፖርትድ። ዛት ሚንስ ይሄኛው አፖርትድ ካልሆነ አፖርትድ ወይንም ሮልባክ እስኪሆን መጠበቅ አለበት ወይንም ኮሚትድ እስኪሆን መጠበቅ አለበት ማለት ነው። ስለዚህ there is a problem, this kinds of problem we call it as uncommitted dependency problem. The third problem is inconsistent analyze problem. Occurs when transaction reads several values but second transactions update some of them during execution and before completions of the first transaction. This kinds of transaction also look in this table. Schedule means time ordered or sequence of transactions, time ordered sequence of important actions taken by one or more transitions. That means when a transaction executes there is a schedule in execution time. Sequence of read or write operations by the concurrent transactions, or a sequence of actions or a sequence of operations. A schedule represents the order in which instructions are executed in system in chronological ordering. We have two schedules, serial schedule and non-serial schedules. Serial schedule schedule where an operations of a transaction are executed consecutively without any interleaving operations from one another. Without any interleaving, that means serial schedule ብለን እንጠራዋለን ማለት ነው። when you see non-serial schedule where operations from a set of concurrent transactions are interleaved, when exists interleaved between the transactions. The other one is serializability. Serializability identifies those executions of transactions guaranteed to ensure consistency. Objective of serializability is to find a schedule that allows transactions to execute concurrently without interfering with one another. So serializability የሚለውን ነገር ዋናው አላማው ምንድን ነው? ዊዛውት ኮንፍሊክት አለ ወይ ወይንም ኢንተርሊቪንግ አለ ወይ የሚለውን ለማየት ስንፈልግ ነው ማለት ነው። ስለዚህ schedules can be executed in serially or non-serially, so it can have some of different problems. So serialization can be used to control these problems, to identify the executions of transaction granulated, guaranteed, to ensure consistency. We have using serializability. If two transaction only read data, order is not important. That means two transaction T1 and T2 uh, can read data item X at the same time. No concurrent or no conflict exists. So no, it is not important, or not it does not any issue if two transactions either read or write completely separate data item. When you read and write operations can be executed in separate data item, this do not conflict also. ይህም ኮንፍሊክት አይኖረንም ማለት ነው። It's not important if one of transaction write at the data item, the other operations read for read or write in the same data item. That means when one transaction, first transaction write a data item, the second transaction read or write a data item, these are executed in. It is important because there may be conflict. There may be a conflict or not. So a possible solution is run all transactions serially. ጀስት እንደዚህ አይነት ኤክስኪዩሽኖች በሚኖሩበት ሰዓት ሰሪያሊ ምን መሆን ማድረግ ይኖርብናል ማለት ነው። ሰሪያሊ ኤክስኪዩትን ማድረግ ይኖርብናል ማለት ነው። ሀው ቱ ቴስት ሰሪያላይዜቢሊቲ፣ ሰሪያላይዜቢሊቲ እንዴት አድርገን ቴስት እናደርገዋለን ነው። ኮንስትሬንትስ ራይት ሩል፣ የመጀመሪያው ራይት ሩል ብለን የምንጠራውን ነው ማለት ነው። ትራንዛክሽን አፕዴትስ ዳታ አይተም ቤዝድ ኦን ኢትስ ኦልድ ቫሊዩ ዊች ኢዝ ፈረስት ሪድ። ዛት ሚንስ ፈረስት ሪድ ባደረገበት ኦልድ ቫሊዩ አፕዴት ማድረግ አለበት። ዛት ሚንስ ራይት ሩል ነው የሚለው ማለት ነው። አንደር ኮንስትሬንት ራይት ሩል ዊ ካን ዩዝ ፕሪሲደንስ ግራፍ ቱ ቴስት ሰሪያላይዜቢሊቲ። ፕሪሲደንስ ግራፍ በመጠቀም ሰሪያላይዜቢሊቲን ቸክ ልናደረግ እንችላለን ማለት ነው። Non-serializable schedule can be tested for serializability by using methods called precedence graph. Precedence graph is composed of nodes and arcs. Node represents a transaction or a number of transactions. Arc represents the connection or the connections of nodes or connections of transactions. Each representation of each transaction in the schedule will be node ብለን እንጠራቸዋለን። the draw የምናደርገው ነገር from t1 ወይንም ti to tj, that means ti tj we call it as arc ብለን እንጠራዋለን ማለት ነው። when tj reads an item that is already written by ti, ti writes x, then tj read x. tj writes an item that already has been read by ti, or ti reads, then tj write. tj writes an item that already has been written by ta. That means ti write, tjm also write. So እንዲህ በምናደርግበት ሰዓት ኮንፍሊክት ይኖረናል ማለት ነው። ኮንፍሊክት ይኖረናል። ኮንከረንት ትራንዛክሽን ናቸው በት ኮንፍሊክት ይኖራል ማለት ነው። ቢኮዝ ኦፍ one of the two are right operations, or one of the two are right operations. There is right operations, there is right operations, there is right operations. After drawing the precedence graphs, if there is any cycle, the graph should be schedule is said to be non-serializable. There is an arc, there is a circle between the transaction. We call it as non-serializable. If there is no cycle in a graph, there is schedule in equivalent or serializable schedule. There is a conflict matrix, read write, when two transactions have execute these operations. So read no any conflict, no any conflict. in write read, yes, there is exists a conflict, there is exists a conflict, there is exists a conflict. So uh, no serializable, no serializable, no serializable. that means ኤክስኪዩት እየሆኑ ያሉት በምንድን ነው ማለት ነው? በኮንፍሊክት ዋይ ነው ማለት ነው። በኮንፍሊክት ዋይ ነው። ፎር ኤግዛምፕል ኦፕሬሽን operations write x of transaction t1 and operations write x of transaction t2 are conflict operation because they satisfies all of the three conditions mentioned in the above. This belongs to different transactions. They are working on the same data item x on the operation to write operations. That means ሁለቱም የሚሰሩት ምን ላይ ነው ማለት ነው? ቫልዩ ዳታ አይተም ኤክስ ላይ ነው። ሶ ዳታ አይተም ኤክስን ይሄኛው ራይት እያደረገ ነው፣ ይሄኛው ደግሞ ሪድ እያደረገ ነው። ሶ አንደኛው ያነበበውን ምንኛው አንደኛው አፕዴት እያደረገ ነው፣ አንደኛው እያነበበ ነው። ስለዚህ there is a conflict operation. when you see example 2 operation write x of a time at transaction 1 and value of አሁን ዳታ አይተም ዋይን ነው ይሄኛው አፕዴት እያደረገ ያለ። ስለዚህ ኖ ኮንፍሊክት ቢኮዝ ዲፈረንት ትራንዛክሽን ዳታ አይተም ሲሚላሪ ዳታ አይተም ኤክስን አፕዴት እያደረገ ነው ትራንዛክሽን 1 ትራንዛክሽን 2 ደግሞ ዳታ አይተም አሚን ትራንዛክሽን 1 አፕዴት እያደረገ ነው፣ አሁንም ትራንዛክሽን 1 ሪድ እያደረገ ነው። ስለዚህ ኖ ኮንፍሊክት ቢኮዝ ቦዝ ኦፕሬሽን ቢሎንግ ቱ ትራንዛክሽን 1 check these the two transactions transaction 1 and transaction 2 there is here it is a time interval ስለዚህ whether it is exist ሳይክል ሶ ሳይክል ካለ ምንድነው ማለት ነው? ነን serializable ነው ማለት ነው። ኦር ሳይክል ከሌለ serializable አይደለም፣ ኮንፍሊክት አለ ማለት ነው። ስለዚህ at T4 transaction 1 reads updates value x no any commit or abort options here. So continue transaction 2 ይቀጥላል ማለት ነው። አፕዴት እያደረገ ነው፣ ሪድ እያደረገ ነው። ይሄኛው ጨረሰ ማለት ነው። there is interleaved ከዋን ወደ ማን ይሄዳል ማለት ነው? ወደ ቱ ይሄዳል። ከቱ ተመልሶ ወደ ዋን ይሄዳል ማለት ነው። and also አሁን ወደ ዋን ይሄዳል። ወደ ዋን የሚሄድበት ምክንያት ደግሞ ምንድነው? ዋይን ኤክስኪዩት አድርጎ አልጨረሰም ማለት ነው። ስለዚህ ሳይክል አለ ማለት ነው። ኢትስ ኦል አባውት ትራንዛክሽን። ኢፍ ዩ ሃቭ ኮስትን ዩ ዌልካም። ቴንክ ዩ ፎር ዩር ሰብስክሪፕሽን።